So if I gave you this example, so your notes packet from yesterday, we left off on example 8. When I am asking you, what does d sub x mean? Derivative. All right, is this one where I could just bring x up and do it an easy way? No, because there's two terms on the bottom. So since it's a fraction, what am I going to have to do? Where have you been?
Well, I was in the drive room. First, I was actually in the library. Then I was.
I agree with you. Okay, so we have to do the quotient rule here. So quotient rule is low, so the bottom one, x squared plus 1, d high. What is the derivative of the top? 0. Minus high, d low. What is the derivative of the bottom? All over low squared. So anything times 0 disappears, so we just get negative 2x over x squared plus 1 squared. Like we said yesterday, technically you could FOIL out the bottom. I don't recommend it only because when we start doing higher derivatives, it's a lot harder to see what reduces when you start multiplying that out. So it's just going to be easier to leave it factored. All right. Let's do some more. Find z prime of t, also known as dz dt, if z is equal to this. So you can use whatever variables you want. I just want you to realize it doesn't have to be x and y. So z prime. Is there any way to simplify this first? No, because two terms on the bottom, so we have to do quotient rule. Why don't you guys try it? So low means the bottom, which is 1 plus t to the 4th. D high means derivative of the top, so negative 3t squared, minus high, so the top, d low, derivative of the bottom, is 4t cubed, over low squared. So then we have to simplify this. So if we distribute, we get negative 3t squared minus 3t to the 6th. I'm going to distribute my negative and my 4t cubed at once. So minus 4t cubed plus 4t to the 6th. And I'm just going to leave the bottom as is. So combining like terms, negative 3t to the 6th plus 4t to the 6th is just 1t to the 6th. So we should get this. I mean, you can reorder those. It doesn't matter what order you put the top terms in. Is that okay? So let's look at another one. I typed this one a little bit different, but it's d to the x over 1 plus x squared. So again, is there any way to avoid using a quotient rule here? No. I want the equation of a tangent line. To write the equation of a line, we need a point and a slope. I have a point. How do you get the slope of a tangent line? Derivative. So y prime. Quotient rule. Low d high. What is the derivative of e to the x?
E to the x.
Minus high D low, what is the derivative of 1 plus x squared?
2x.
Over low squared. Okay, so you can distribute but do we have any like terms or anything to combine here? No. But keep in mind, we're trying to write the equation of the tangent line. So the slope, to get an actual number for my slope, what am I going to do?
Plug in the point.
Yeah. So if I plug in, my x here is 1. So if I put in 1 for all my x's, I get e to the first, which is e, plus 1 squared times e is still e, minus 2 times e, over 2 squared, which is 4. What do we get? E plus e is 2e. 2e minus 2e is
0. This e is not.
So now I have a point and a slope. So y equals mx plus b. So the equation is 0x plus 1/2 e, or y equals 1/2 e. It's just a horizontal line. Any questions there? The next slide is just a summary of what we have done with derivatives so far. So derivative of a constant is 0. We know if we have x to a power, the power comes down, subtract 1. Derivative of e to the x is still e to the x. If you have a constant, you can pull it out. If you're adding, subtracting, you can do one at a time. Multiplying, we have product rule. Dividing, we have quotient rule. So this is what we have learned about derivatives so far. So, game plan. You have a handout from yesterday that I want done by the end of the hour. So we will turn that one in at the end. And then if you finish that, you can start working on these blocks.
See if I did it correctly.
It's easier tomorrow.